Hello everyone, welcome in the episode 2 of RTOS series. So in last episode, we have developed a multitasking system using RTOS, FreeRTOS, and we have used two different functions, start task LED1 and LED2. In one of the tasks, we blink port 7's LED, port PB7's LED with interval of 200 millisecond, and second is PB14 with interval of 1000 millisecond. And we have also seen the hardware demonstration as well. Right now, what happened in this program is when this task start toggling the LED, immediately after this it will go into sleep mode for some time, you can say 200 millisecond, and during this interval CPU can do another task. Okay, so this RTOS will take the second ready task which is to be executed by the operating system, right? And this is how these two tasks continuously share that CPU and continuously execute in a sequence one by one. And here you can see this task 1 or task 2, none of the task is blocking any other task, right? Because after operation they are simply going to sleep mode, you can say, right? So they are like this is for specific this function only. Same way with this. So after executing this for 1 second, this task will go into sleep mode, or you can say it will release the resources, so the another task can be executed. So it's basically multitasking concept, right? And now one more thing, here also we have set some priority, if you remember, right? So let me just show you the priority. So this is the registration, you can say tasks, and here is the priority. You can see LED1's task priority was high and LED2 was normal. So now in this lecture we will see the preemptive scheduling, right? This is normal scheduling, you can say time based, but now since the priorities are different for one task and another task, we will try to write some logic so that one task will take resources for longer period, okay, and for that particular period how CPU will work, or how operating system will allow the other function to execute or not, right? This is what we are going to see. And for that, first of all, what is preemptive scheduling? So what it means when high priority task interrupt a low priority one, and why that matter for beyond blinking LED, right? So this is what we are going to understand in today's episode. So high priority task doesn't wait, it turns. Moment it's ready to run, it takes CPU immediately, even midway through whatever the lower priority task was doing, right? So this is what called preemptive scheduling. In time based scheduling, what happened? One task will execute for 200 milliseconds, then another task will come into picture, then another task will come into picture. Now the core concept of RTOS is multitasking as well as some fixed type of scheduling. So one of them is called preemptive, and this is purely based on priority, right? So let us consider some real world example, right? So for that I'm just using this ambulance example, right? So think like one traffic signal is there, right? Car are moving through green light, normal everyday traffic. This is, we can say, another task for LED2, right? So it's low urgency because the priority is normal, running continuously, taking its turn like everyone else. Now ambulance approaches with its siren on, okay? So ambulance will have definitely higher priority, right? Because some emergency is there. So traffic doesn't finish its current green light cycle first. Signal and vehicle react immediately. So even traffic signal is showing green light, but since the priority is high for that ambulance, the other the signal and vehicle will react immediately, clearing the way right then, and then LED1 or higher priority, and that moment needs the road, right? Everything else stops making progress until it's through. It means that when ambulance comes, everything will stop, everything will give their own path for the ambulance, and they will allow that ambulance to be passed through the road, right? So that the concept, the meaning behind this example is that whenever high priority task is there, that must execute, okay, beyond any time based rules. Another example, you can say drone flight, right? Let us say you have one microcontroller over the drone. One is adjusting the turbulence related things, right? It's basically flying related things, and another is simply sending images. Now something happen like a turbulence or something environmental related issue is there. So now the sensor will give the signal to microcontroller that we have to do something for this to adjusting the flying related parameter, or you can say you have to fight with the turbulence. So now at that time the microcontroller will not think about sending images, because that is secondary task. It is very low, least priority. Even if drone will not send image for 1 or 2 minutes, it doesn't care, right? It means it will not affect an overall operation. But if instead of adjusting its speed or something like that, it means that instead of fighting with the turbulence, if controller will give priority to sending images, then your drone will be crashed, right? So that is why the priority is most important thing. And in the same code which we did in first episode, I will modify something and show you how priority scheduling works, right? So mapping the example, normal traffic like LED2. Okay, so in our code, LED2 is there. It's a normal priority, and LED1 is a higher priority. Okay, so LED2 is normal priority, ambulance and LED1 wakes up, high priority task. And until this task will execute, the operating system will not release the resources for any other task. It will allow this LED1 to finish its work, and then it will move and start executing LED2 normally until after LED1 finish the job. Okay, so this is what the overall concept is. Now let us check our code. And again, this is very basic operation, right? Whatever we did in our first episode, LED task 1, LED task 2. Okay, now what we will do, simply we will change this LED1 task. Okay, so what I will do, I will simply add something here, so that LED1 task will take some time, and during that time the operating system will not allow any other resources to use the CPU, right? So first of all, I'm just defining one variable. Start. Okay, now this is for infinite logic, so let us add some delay. So after, let us say 3 seconds, this task will wake up. Okay, so until this time period, this task will be in sleep mode only. So consider like for 3 seconds, ambulance will be not there on the road. Okay, so normal traffic should go. Now let us load the time. We'll start. Okay, and let us wait for 2 seconds. For 2 seconds, this ambulance will take time of 2 seconds to pass through that signal. So it will simply check the difference between start time and next after 2 seconds, you can say. $2,000. Okay, let me check the logic. Okay, so it will continuously wait for 2 seconds. Again, this is blocking. Okay, we are intentionally blocking this for 2 seconds, and we will do nothing, right? Right, I would like to simply write here busy for 2 seconds. That's it. Okay, and after 2 seconds, it will release the resource. So instead of toggle pin, let us use the write pin function. Okay, I think that we all know. So instead of HL GPIO toggle, we have to write pin. So for this much period, the LED will remain on, or you can say set. Okay, and after this, it should reset. Okay, and let not change anything here. And instead of 1000, let us set it to 100 milliseconds, so we can observe the blocking time, because otherwise what happen, after 1 second this LED will blink, so it will not observable, I would say, right? So let us set this to 100 milliseconds. So what happened, as per our first episode, first it will execute this task, then it will execute this task. Okay, now what happened with this preemptive scheduling, let us say after 300 milliseconds or 3 seconds, this LED will continuously blink. Okay, but after 3 seconds, then this high priority task will start execute. Okay, it will not allow this function to execute until this task will finish. And what we are doing in this function, we are intentionally setting 2 seconds delay. Okay, so after 3 seconds, for continuous 2 seconds, this function will take resources, And because this high priority task is there, because the high priority task is trying to execute something, it will allow this task to execute and it will block all other tasks. Okay, again here we are simply using 2 tasks, but even if we have many tasks, but first it will only and only allow high priority task. Okay, so for that let us compile the code. Now I will show you normal operation. First of all, on board. Now I'm just loading this. You can see task 2 is continuously executing. Now as task 1 awake, you can see task 2 is blocked by this operating system. This is blocking period. Again execute, again wake up. Now again block for 2 seconds, again execute. Right, so you can see we have simply changed one function only, right? And because of that, higher priority task takes resources for 2 seconds. Operating system will not allow any other resources to execute, any other function to execute for that time period, right? And once high priority task finished, or once ambulance passes through the road, it will allow other normal priority tasks, right? So this is how the priority based scheduling, or you can say preemptive scheduling, works. Okay, so this is what for this video. Thank you.